So we'll start with the first inequality, and that's your fundamental AM, GM and HM inequality. So the very first inequality is AM, GM, HM inequality. If we have n positive real numbers a1, a2, a3 up to an, where each of these numbers they are positive real numbers, then we can define their arithmetic mean as their sum a1 plus a2 up to an whole divided by n, their geometric mean as their product a1, a2, an to the power 1 by n, and their harmonic mean as n upon 1 upon a1 plus 1 upon a2 up to 1 upon an. Now relationship between the three means is arithmetic mean is always greater than or equal to geometric mean, that is always greater than or equal to harmonic mean for positive real numbers. So for positive real numbers, their arithmetic mean will always be greater than their geometric mean and will always be greater than their harmonic mean. Now here we have two cases. Case 1, we have this equality sign AM, it is equal to GM and it will be equal to HM if and only if all the numbers are same. So this equality sign is only possible when all these numbers they are same. And we have this second condition when at least one AI is unequal to AJ or numbers are distinct. So at least we have one number which is different from all other numbers. In that case, arithmetic mean is always strictly greater than their geometric mean and will be strictly greater than their harmonic mean. Now since this AM, it is related to sum and GM, it is related to product, you'll find many situations where it will be given that either sum is constant or product is constant. So if sum is constant, they'll ask you to find maximum value of the product, and if product is constant, then they'll ask you minimum value of the sum. So these are some common problems that you'll find in AM, GM and HM inequality. Now this inequality is so fundamental that it is extensively used in every portion of mathematics. Now let us take up some examples. Now the first question is, if A, B, C are three positive real numbers. So we have three positive real numbers. So A, B, C, they are positive real. Then which of the following is or are true? Now this first one is A square plus B square plus C square. It is greater than or equal to BC plus CA plus AB. So for this first one, what we'll do is we'll take three numbers as A square, B square and C square, and we'll write their arithmetic geometric mean inequality taking two at a time. So if we take A square and B square, we can write A square plus B square by 2. It is greater than or equal to A square B square to the power 1 by 2, which is simply AB. In the same way, we can write it for B square and C square. So B square plus C square by 2, it is greater than or equal to BC, and C square plus A square by 2, it is greater than or equal to CA. Now, if we add all these three, then in the numerator we'll have 2 times A square plus B square plus C square whole divided by 2 and will be greater than or equal to AB plus BC plus CA. Now we can cancel this 2 with 2. So we'll get this result as A square plus B square plus C square. It is greater than or equal to AB plus BC plus CA. That means this option A is correct. Now this result, it is an important result in mathematics, and the version which is mostly used in JEE Advanced is this version. You will be given A square plus B square plus C square, and it is equal to AB plus BC plus CA. Now we know that we'll have this equality when AM is equal to GM, and AM is equal to GM if and only if numbers are same. So from here we'll get this condition that A must be equal to B, it must be equal to C. So if we have this strict equality, then all three numbers, they'll be same. Another way to solve the same question is, we can write this as a square plus b square plus c square minus ab minus bc and minus ca. Now what we'll do is, we'll multiply and divide everything with 2. So we can write this as 1 by 2 and it'll be this 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Now we'll take a square plus b square and 2ab. Then we'll take b square plus c square 2bc. And then we'll have a square plus c square minus 2ca. So we can write this as 1 by 2. And here will be this a minus b square plus b minus c square plus c minus a whole square. Now we know that sum of squares is always greater than or equal to 0. So from here again we can write a square plus b square plus c square will be greater than or equal to ab plus bc plus ca, and we'll have this equality sign if each of the squares is 0. That means we'll have this equality sign, that is a square plus b square plus c square, it is equal to ab plus bc plus ca if a is equal to b and b is equal to c. So that's our option A. Now we'll come to this option B. Now option B is direct application of AMGM. So we have three numbers, a cube, b cube and c cube. They are all positive real numbers. We can write their arithmetic mean. So it will be a cube plus b cube plus c cube by 3. It will be greater than or equal to their geometric mean. So there will be a cube, b cube, c cube to the power 1 by 3, which is ABC. So we rearrange, we can write a cube plus b cube plus c cube. It is always greater than or equal to 3 times ABC, which means this option B is also correct. Another way to write this is, we know that a cube plus b cube plus c cube minus 3abc, it is a plus b plus c into a square plus b square plus c square minus ab minus bc and minus ca. Now we know that ABC are all positive real numbers, so this is a positive real number, and in the first part we have proved that this expression is always greater than or equal to 0. So from here again we can write a cube plus b cube plus c cube, it is greater than or equal to 3abc. Now we'll come to part C. In part C, we are given three products and we have to prove that it is greater than or equal to 8abc. Now here what we'll do is, we'll take three numbers as ABC and we'll write their AMGM, again taking two at a time. So we can write a plus b by 2. It is greater than or equal to under root AB. B plus c by 2. It is greater than or equal to under root BC, and c plus a by 2 is greater than or equal to under root ca. Now we multiply all these three, we can write a plus b into b plus c into c plus a whole divided by 8, and it is greater than or equal to under root a into under root a. So there will be a, in the same way it will be b and c. So we can write it is greater than or equal to abc, or simply a plus b into b plus c into c plus a. It is greater than or equal to 8 ABC. That means this option C is also correct. Now this option D is, we need to prove that BC upon A plus CA upon B plus AB upon C, it is greater than or equal to A plus B plus C. Now for this, what we'll do is, we'll divide everything with ABC. So we can write 1 upon A square plus 1 upon B square plus 1 upon C square will be greater than or equal to 1 upon BC plus 1 upon CA plus 1 upon AB. So this first inequality, it is equivalent to its second form. Now we'll prove this the way we have proved this first one. So it is same as this first one, but in case of ABC, we are taking 1 upon A, 1 upon B and 1 upon C. So we can write 1 upon A square plus 1 upon B square by 2 will be greater than or equal to their geometric mean, which is 1 upon AB. In the same way, 1 upon B square plus 1 upon C square by 2, it is greater than or equal to 1 upon BC and 1 upon C square plus 1 upon A square by 2. It is greater than or equal to 1 upon CA. Now, if we add all these three, we'll get this result. That means this statement D is also correct. So the correct options are A, B, C, D. Let us take another example. Now here the question is, find the maximum value of this expression for x greater than 0. So here x is a positive number. Now our expression is y equals x plus 1 upon x to the power 6 minus x to the power 6 plus 1 upon x to the power 6 minus 2 upon x plus 1 upon x whole cube plus x cube plus 1 upon x cube. Here what we'll do is we'll take this minus 2 with this second expression. So we can write this as minus, and here will be this x to the power 6 plus 1 upon x to the power 6 plus 2, which actually is a square plus b square plus 2ab. So we can write this as y equals x plus 1 upon x whole to the power 6 minus, and here it is x cube plus 1 upon x cube whole square whole divided by x plus 1 upon x whole cube plus x cube plus 1 upon x cube. Now what we'll do is, in the numerator we have x plus 1 upon x to the power 6. We'll write this as x plus 1 upon x to the power 3 whole to the power 2. Now this is a square minus b square. So using the formula, we can write this as y equals a plus b, and there will be x plus 1 upon x whole cube plus x cube plus 1 upon x cube into a minus b, and that will be x plus 1 upon x whole cube minus x cube minus 1 upon x cube whole divided by x plus 1 upon x whole cube plus x cube plus 1 upon x cube. Now this expression, it gets cancelled. So now we can write this as y equals x plus 1 upon x whole cube minus x cube minus 1 upon x cube. Now this is a plus b whole cube, so there will be a cube plus b cube plus 3a square b plus 3ab square, and then we have this minus x cube minus 1 upon x cube. Now these two, they get cancelled. So this y will be 3 times x plus 1 upon x. Now we have to find minimum value of their sum, and we know that if we multiply them, their product is 1. So their GM will be constant. So here we'll use AM and GM. So if we use AM and GM, we can write x plus 1 upon x by 2. It is greater than or equal to under root of x into 1 by x, which is 1. So we can write this as this x plus 1 by x. It is greater than or equal to 2. Now, if x plus 1 upon x is greater than or equal to 2, then this y, it is greater than or equal to 6. So minimum value of this expression will be simply 6.
जो क्वेश्चन हम पढ़ेंगे उसका नाम है नेस्बिट्स इनइक्वालिटी, और इनइक्वालिटी कहता है कि अगर हमारे पास 3 पॉजिटिव रियल नंबर्स a, b और c हैं, तो a अपॉन b प्लस c प्लस b अपॉन a प्लस c प्लस c अपॉन a प्लस b का जो वैल्यू आएगा वो हमेशा 3/2 या 3/2 से बड़ा होगा। अब इस क्वेश्चन को सॉल्व करने का पहला तरीका है हमारा सबसे फंडामेंटल इनइक्वालिटी, जिसको हम बोलते हैं AMGM HM इनइक्वालिटी। तो इस क्वेश्चन के लिए हम यूज करेंगे AM HM इनइक्वालिटी। अब ये क्वेश्चन के लिए हम 3 नंबर्स कंसीडर करते हैं, b प्लस c, a प्लस c और a प्लस बी। अब इनका अगर अर्थमेटिक मीन लिखेंगे तो हम लिखेंगे b प्लस सी प्लस a प्लस सी प्लस a प्लस बी डिवाइड बाई 3, और ये बड़ा होगा या बराबर होगा इसके हार्मोनिक मीन से 3 अपॉन 1 अपॉन बी प्लस सी प्लस 1 अपॉन ए प्लस सी प्लस 1 अपॉन ए प्लस बी के। अब इस न्यूमरेटर को देखें तो ये 2a प्लस बी प्लस सी हो जाएगा। तो अपने इसको क्या कर सकते हैं, इसको लिख सकते हैं 2 टाइम्स a प्लस बी प्लस सी, और ये राइट हैंड साइड के डिनोमिनेटर को यहां मल्टीप्लाई कर देता है। तो इसको लिखेंगे 1 अपॉन बी प्लस सी प्लस 1 अपॉन ए प्लस सी प्लस 1 अपॉन ए प्लस बी, और ये बड़ा होगा या बराबर होगा 9 के। अब इस 2 को भी इधर ले जाता है और इस a प्लस बी प्लस सी को इन तीनों से मल्टीप्लाई कर देता है। तो इसको लिखेंगे a प्लस बी प्लस सी अपॉन बी प्लस सी प्लस a प्लस बी प्लस सी अपॉन ए प्लस सी प्लस a प्लस बी प्लस सी अपॉन a प्लस बी, एंड दिस इज ग्रेटर देन इक्वल टू 9/2। अब यहां पे इसको 2 पार्ट में स्प्लिट करेंगे, a अपॉन बी प्लस सी और b प्लस सी अपॉन बी प्लस सी, जो कि 1 हो जाएगा। तो ये हो गया a अपॉन बी प्लस सी प्लस 1। इसी तरीके से दूसरे वाले को हम लिख सकते हैं b अपॉन a प्लस सी प्लस 1, और ये तीसरा वाला हो गया c अपॉन a प्लस बी प्लस 1, एंड दिस इज ग्रेटर देन इक्वल टू 9/2। तो इसको रीअरेंज करेंगे तो ये हो जाएगा a अपॉन बी प्लस सी प्लस बी अपॉन ए प्लस सी प्लस सी अपॉन ए प्लस बी। दिस इज ग्रेटर देन और इक्वल टू 9/2 minus 3, and 9/2 minus 3 is 3/2, which completes our proof. अब हम देखेंगे हमारा दूसरा प्रूफ जो कि है सब्स्टिट्यूशन। अब सब्स्टिट्यूशन में अपने b प्लस सी को x मान लेते हैं, a प्लस सी को y मान लेते हैं, और a प्लस बी को z मान लेते हैं। अगर तीनों को ऐड करेंगे तो यहां से हमारे पास आ जाएगा a प्लस बी प्लस सी, और ये हो जाएगा आपका x प्लस वाई प्लस जेड डिवाइड बाय 2। अब यहां से अगर a का वैल्यू निकालना है तो b प्लस सी को इसमें सब्ट्रैक्ट कर देंगे, तो यहां से a हो जाएगा आपका x प्लस वाई प्लस जेड अपॉन 2 माइनस x, जो कि हो जाएगा y प्लस जेड माइनस x अपॉन 2। और इसको अगर b प्लस सी से डिवाइड करना है तो x से डिवाइड करेंगे, तो ये हो जाएगा a अपॉन b प्लस सी, और ये हो गया आपका y प्लस जेड माइनस x बाय 2x। तो लेफ्ट हैंड साइड में जो एक्सप्रेशन है इसको अगर हम x वाई जेड के टर्म्स में लिखेंगे तो ये हो जाएगा y प्लस जेड माइनस x अपॉन 2x प्लस x प्लस जेड माइनस y अपॉन 2y प्लस x प्लस वाई माइनस जेड अपॉन 2z। अब एक काम करते हैं, ये x, y और z के टर्म्स को अलग कर लेते हैं और बाकी टर्म्स को अलग लिखते हैं। तो इसको अपने लिख सकते हैं 1/2, ये हो गया y अपॉन एक्स प्लस z अपॉन एक्स प्लस x अपॉन वाई प्लस z अपॉन वाई प्लस x अपॉन z प्लस y अपॉन z। तो ये 6 एक्सप्रेशन हो गए, और ये हो गया आपका -1/2 -1/2 -1/2, जो कि हो गया आपका -3/2। अब अगर इस एक्सप्रेशन को देखें तो ऊपर हमारे पास 2y है, नीचे भी 2y है, 2z है, नीचे भी 2z है, ऊपर 2x है, नीचे भी 2x है। तो इन सबको मल्टीप्लाई करेंगे तो इसका वैल्यू 1 आएगा। तो क्लियरली हमें पता है कि अगर इसमें हम AMGM यूज करें तो हम इसका मिनिमम वैल्यू निकाल सकते हैं। तो हम क्या करेंगे, साइड में इसका मिनिमम वैल्यू निकालेंगे। तो अगर इसमें AMGM यूज करते हैं तो ये हो जाएगा आपका y अपॉन एक्स प्लस z अपॉन एक्स प्लस x अपॉन वाई प्लस z अपॉन वाई प्लस x अपॉन z प्लस y अपॉन z डिवाइड बाई 6, और ये बड़ा है बराबर है इसके ज्योमेट्रिक मीन से जो कि है इनका प्रोडक्ट जो कि 1 है टू द पावर 1/6। अब 6 को इधर ले जाते हैं तो इसका मतलब ये जो y अपॉन एक्स प्लस z अपॉन एक्स प्लस x अपॉन वाई प्लस z अपॉन वाई प्लस x अपॉन z प्लस y अपॉन z का जो वैल्यू आएगा वो आएगा आपका 6 या 6 से बड़ा। अगर यहाँ पे सब्स्टिट्यूट करते हैं तो ये बड़ा होगा या बराबर होगा 1/2 इंटू 6 माइनस 3/2। तो ये हो गया 3 माइनस 3/2 मतलब 3/2। तो ये हो गया हमारा दूसरा तरीका इस इनइक्वालिटी को सॉल्व करने का। अब हम चलते हैं हमारे सातवें प्रूफ की तरफ और इसमें हम यूज करेंगे एएमजीएम और सब्स्टिट्यूशन। तो ये बेसिकली है हमारा एएमजीएम और सब्स्टिट्यूशन को यूज करके। तो यहां पे हम मान लेते हैं कि b प्लस सी एक्स है, a प्लस सी वाई है और a प्लस बी जेड है। तो ये इनइक्वालिटी को सॉल्व करने की बजाय हम एक दूसरा इनइक्वालिटी सॉल्व करेंगे जो कि है x प्लस जेड अपॉन वाई प्लस y प्लस जेड अपॉन एक्स प्लस x प्लस वाई अपॉन जेड। अगर इसको हम 6 नंबर्स में अलग अलग डिवाइड करेंगे तो हमको पता है इसका ज्योमेट्रिक मीन 1 आएगा। तो इसका अगर अरिथमेटिक मीन देखेंगे तो यहाँ पे इनको हम 6 नंबर्स के जैसे ले रहे हैं तो इसके अरिथमेटिक मीन में डिवाइड बाई 6 आएगा और ये बड़ा है या बराबर है इसके ज्योमेट्रिक मीन से। अब ये 6 नंबर्स का प्रोडक्ट 1 आएगा तो इसका जीएम 1 हो गया। तो यहां से हम लिख सकते हैं x प्लस जेड अपॉन वाई प्लस y प्लस जेड अपॉन एक्स प्लस x प्लस वाई अपॉन जेड, ये बड़ा है या बराबर है 6 के। अब यहां से एक्स वाई जेड का वैल्यू पुट कर देता है। अब यहां पे x प्लस जेड जो आएगा वो आएगा आपका a प्लस 2b प्लस सी अपॉन y है आपका a प्लस सी के। इसी तरीके से y प्लस जेड हो जाएगा आपका 2a प्लस b प्लस सी अपॉन b प्लस सी प्लस x प्लस वाई हो गया आपका a प्लस बी प्लस 2c अपॉन a प्लस बी और ये बड़ा है बराबर है 6 के। अब इसको दो पार्ट में स्प्लिट करते हैं तो a प्लस सी अपॉन a प्लस बी 1 हो गया। तो ये गया 1 प्लस 2 इंटू बी अपॉन a प्लस, इसी तरीके से ये हो गया 1 प्लस 2 इंटू a अपॉन बी प्लस सी और ये हो गया आपका 1 प्लस 2 इंटू सी अपॉन a प्लस बी और ये बड़ा है बराबर है 6 के। अब 1 प्लस 1 प्लस 3 6 माइनस 3 इज 3 और 2 को इधर ले जाएंगे तो डायरेक्टली हमने लिख सकते हैं कि b अपॉन a प्लस सी प्लस a अपॉन b प्लस सी प्लस c अपॉन a प्लस b, ये बड़ा है बराबर है 3/2 के। Now the second inequality is weighted AMGM inequality. So suppose we have n positive real numbers a1, a2, a3 up to an, where each of ai it is a positive real number and we have n positive rational numbers which are suppose w1, w2, w3 up to wn, and we'll take them as weights of a1, a2, a3 and an. So these wi's, they are positive rational numbers. Then we can write their weighted arithmetic mean as this am star, and it will be w1 a1 plus w2 a2 up to wn an upon w1 plus w2 up to wn, and we can write their weighted geometric mean as a1 to the power w1, a2 to the power w2 and an to the power wn whole to the power 1 upon w1 plus w2 up to
Wn. Now let us take an example. Say for example, we have three positive real numbers a, b and c. So these a, b and c, they are positive real numbers, and let us consider their weights as 1, 2 and 3. Then we can write their weighted am as 1 into a plus 2 into b plus 3 into c upon 1 plus 2 plus 3, and there will be a plus 2b plus 3c upon 6, and we can write their weighted GM as a to the power 1, b to the power 2, c to the power 3, whole to the power 1 upon 1 plus 2 plus 3, and there will be a b square c cube to the power 1 by 6. So this is how we write weighted AMs and weighted GMs. Now if we closely look at these weighted AMs and GMs, it simply means that we are considering numbers in which A is taken one time, we have taken this B two times, and we have taken this C three times. So it will be this A, B, B, C, C, C. If we write their arithmetic mean, it will be A plus B plus B plus C plus C plus C whole divided by total numbers is 6. So that will be A plus 2B plus 3C whole divided by 6. So essentially, it is arithmetic mean of 6 numbers rather than 3 numbers. In the same way, if we write their geometric mean, it will be A into B into C into C into C whole to the power 1 by 6, which is A B square C cube to the power 1 by 6. So basically they are AM and GM of these 6 numbers. Now here the fundamental is, if AM star is weighted AM of these n numbers and GM star is weighted GM of these n numbers, then their weighted arithmetic mean will always be greater than or equal to their weighted geometric mean. So weighted AM is always greater than or equal to weighted GM for n positive real numbers having positive rational weights. And again here we'll have this equality. So this AM star will be equal to GM star if and only if A1 equals A2 equals AN. Now let us take up an example. We are given that X, Y and Z are positive real numbers. So X, Y and Z, they are positive real numbers such that X into Y into Z, it is equal to 32. Then we have to find minimum value of x square plus 4xy plus 4y square plus 2z square. Now clearly we know we have to find minimum value of sum, and we are given something of this product x, y, z. So we have to use AM and GM. But the problem here is, if we want to multiply these 4 expressions, then we get x square into 4xy into 4y square into 2z square, and then we'll have x cube, y cube and z square. So we'll get this expression as xy cube into z square, but we are given that x into y into z is constant. So this expression on the geometric mean side, it won't be a constant, so you won't be able to get this minimum value. Now this problem can be resolved if we want to use weighted AMGM. So what we'll do is, we'll consider 4 numbers as x square, 2xy, 4y square and z square, and we'll consider their weights as 1, 2, 1 and 2. Now if you want to write their weighted arithmetic mean, it will be x square plus 2 into 2xy plus 4y square plus 2z square upon 1 plus 2 plus 1 plus 2. So their weighted AM will be x square plus 4xy plus 4y square plus 2z square whole divided by 6. Now we can write their weighted GM. LB x square and then 2xy whole square, 4y square to the power 1 and then z square whole to the power 1 by 6. Now it will be 2 square into 4, there will be 2 to the power 4, then x square into x square, x to the power 4, y to the power 4 and z to the power 4 whole to the power 1 by 6. Now we can write this as 2xyz whole to the power 4 by 6. Now x into y into z is 32. So this is 64 and 64 is 2 to the power 6. So we can write this as 2 to the power 6 whole to the power 1 by 6. I'll cancel. This is 16. We know that weighted AM is always greater than or equal to weighted GM. So from here we can write x square plus 4xy plus 4y square plus 2z square divided by 6 is always greater than or equal to 16. So from here we can write x square plus 4xy plus 4y square plus 2z square is greater than or equal to 16 into 6 and it is 96. So minimum value of this expression is 96. That means the correct option is this option C. Now let us take another example and it says the minimum value of sum of real numbers a to the power minus 5 plus a to the power minus 4 plus 3 a to the power minus 3 plus 1 plus a to the power 8 plus a to the power 10 where a is greater than 0. Now we have to find minimum value of this sum and each of these numbers they are positive real numbers. So clearly we can use AM and GM. But the problem here is if we multiply the powers of a, it will be a to the power minus 5 into a to the power minus 4 into a to the power minus 3 into a to the power 8 and a to the power 10. Now these negative powers they come to a to the power minus 12 and these positive powers are a to the power 18. So their GM it won't be constant, but we have this 3 here. So if we consider this a cube 3 times, then we'll have a to the power minus 18 here, and in that case this GM will be a constant number. So for this question we'll consider these 6 numbers a to the power minus 5, a to the power minus 4, a to the power minus 3, 1, a to the power 8 and a to the power 10 with weights 1, 1, 3, 1, 1 and 1, and if we write their weighted AM it will be a to the power minus 5 plus a to the power minus 4 plus 3 a to the power minus 3 plus 1 plus a to the power 8 plus a to the power 10 whole divided by, now this is 3 plus 3 6 plus 2 8, and their weighted GM it will be a to the power minus 5 into a to the power minus 4 into a to the power minus 3 cube into 1 into a to the power 8 into a to the power 10 whole to the power 1 by 8. Now this is a to the power 0 which is 1. So their GM will be 1. Now again we have to use weighted AM and weighted GM. So weighted AM star will be greater than or equal to weighted GM. So we can write a to the power minus 5 plus a to the power minus 4 plus 3 a to the power minus 3 plus 1 plus a to the power 8 plus a to the power 10 divided by 8. It is greater than or equal to 1, or simply we can write a to the power minus 5 plus a to the power minus 4 plus 3 a to the power minus 3 plus 1 plus a to the power 8 plus a to the power 10 is always greater than or equal to 8. Therefore, its minimum value is simply 8. That means answer to this question is this option C. Now the third inequality that we'll study is mth power arithmetic mean. So if we have n positive real numbers, say a1, a2, a3 up to an, and they are all positive real numbers, and we have a real number m, then we have three cases depending on the value of m. The first case is if m belongs to r minus 0, 1, that is either m is less than 0 or m is greater than 1. In that case, arithmetic mean of mth power of these numbers, which is a1 to the power m plus a2 to the power m up to an to the power m whole divided by n, will be greater than or equal to mth power of their arithmetic mean. So it will be greater than or equal to a1 plus a2 up to an by n whole to the power m. So this is true if m is less than 0 or m is greater than 1. Now we take an example. Say for example, we consider m as 2. Then this left hand side will be a1 square plus a2 square up to an square by n, which is arithmetic mean of their squares, and will be greater than or equal to square of their arithmetic mean, and which is a1 plus a2 up to an upon n whole square. Now this m, it can be a negative number also. We can take this m as, say, minus 1 by 2. Then we can write a1 to the power minus 1 by 2 plus a2 to the power minus 1 by 2 up to an to the power minus 1 by 2 by n, and will be greater than or equal to a1 plus a2 up to an by n whole to the power minus 1 by 2. So this is our first case when m is either less than 0 or greater than 1. Now we have the second case when m lies between 0 and 1. So the second case when m lies between 0 and 1, in that case, sign of inequality, it reverses. So simply we can write a1 to the power m plus a2 to the power m up to an to the power m whole divided by n will be less than or equal to a1 plus a2 plus an upon n whole to the power m. So if m lies between 0 and 1, then the sign of this inequality, it changes. So if we take an example, suppose we consider m as 1 by 3, we can write a1 to the power 1 by 3 plus a2 to the power 1 by 3 up to an to the power 1 by 3 whole divided by n will be less than or equal to a1 plus a2 up to an by n whole to the power 1 by 3. And then we have this third and trivial case if m belongs to this set containing 0 and 1. So if m is 0 or m is 1, in that case, both the expressions, they'll be equal. So we can write a1 to the power m plus a2 to the power m up to an to the power m whole divided by n will be equal to a1 plus a2 up to an by n whole to the power n. So we have this equality when the value of m is either 0 or 1. Now let us take one example. It says prove that under root 1 plus under root 2 up to under root n, it is less than n into under root n plus 1 by 2. So here what we'll do is we'll consider n numbers 1, 2, 3 up to n, and we'll consider their mth power AMs using m as 1 by 2. Now since m lies between 0 and 1, we have to use its second form. So we can write 1 to the power 1 by 2 plus 2 to the power 1 by 2 up to n to the power 1 by 2 whole divided by n will be less than. And here we are using this strict inequality because all these numbers, they are distinct, they cannot be equal. So it will be less than square root of their arithmetic mean, which is 1 plus 2 plus 3 up to n whole divided by n to the power 1 by 2. Now we can write this as under root 1 plus under root 2 plus under root 3 up to under root n divided by n, and it will be less than, this is sum of first n natural numbers. So it will be n plus 1 upon 2, and here we have this n to the power 1 by 2. Now this n will cancel, so it will be under root of n plus 1 by 2. Now if we rearrange, we can write this as under root 1 plus under root 2 plus under root 3 plus under root n will be less than n into under root of n plus 1 by 2, which is what we need to prove in this question. Now let us take another example, and this is too small, so what I'll do is I'll write the question. Now it says let a, b, c be three positive real numbers. So we have three positive real numbers a, b, c. They are all greater than 0 such that a plus b plus c is 1. Then we have to find minimum value of 1 upon a square plus 1 upon b square plus 1 upon c square. Now here what we'll do is we'll use mth power am for ABC, considering m as minus 2. Now we know that a to the power minus 2 plus b to the power minus 2 plus c to the power minus 2 upon 3 will be greater than or equal to a plus b plus c by 3 whole to the power minus 2. Now it is given that a plus b plus c is 1. So it will be 1 upon 3 to the power minus 2, which is 9. So from here we can write 1 upon a square plus 1 upon b square plus 1 upon c square will be greater than or equal to 27. So minimum value of this expression is 27, and that is the answer to this question. Now the fourth inequality that we'll study is power mean inequality. Now before learning this inequality, we must understand power means. If we have n positive real numbers a1, a2, a3 up to an, and they are positive real numbers, and we have a real number k which is unequal to 0, then their power mean mk a1, a2, a3 up to an, it is defined as a1 to the power k plus a2 to the power k up to an to the power k whole divided by n to the power 1 upon k, where k is a real number and it is not equal to 0. To understand this, let us consider power mean of AB if k is 3. Now it will be this a cube plus b cube by 2 whole to the power 1 by 3. So this is how we write power mean of these numbers with the given k. Now the fundamental here is, if we have non-zero real numbers k1 and k2 such that k1 is greater than k2, then mk1 a1 a2 an is always greater than or equal to mk2 a1 a2 up to an. So that is the fundamental for power means. So if we have three positive real numbers a, b and c, then we know that 3 is greater than 2 and it is greater than 1. Then we can simply write m3abc will be greater than or equal to m2abc and will be greater than or equal to m1abc. which simply means a cube plus b cube plus c cube upon 3 to the power 1 by 3, it will be greater than equal to a square plus b square plus c square upon 3 to the power 1 by 2 and will be greater than equal to a plus b plus c by 3. So this is how we're going to use power mean inequality. Now let us take up an example. Say for example, it says if a, b, c are positive real numbers. So we have positive real numbers a, b and c, and we have to prove that 9 a cube plus b cube plus c cube is greater than equal to a plus b plus c whole cube. We can solve this question using mth power am. Here we are going to solve it using power mean inequality. Now we know that m3 abc will be greater than equal to m1 abc. Now m3 abc is a cube plus b cube plus c cube upon 3 to the power 1 by 3 and will be greater than equal to a plus b plus c by 3. Now if we take cube both sides, then we can write a cube plus b cube plus c cube upon 3 will be greater than or equal to a plus b plus c whole cube upon 27. Now we can cancel this 3 with 27, so it will be this 9. So if we rearrange, we can write 9 times a cube plus b cube plus c cube will be greater than equal to a plus b plus c whole cube, which is what we need to prove in this question. Now let us take another example, and here we have to prove that a cube plus b cube plus c cube upon a square plus b square plus c square is greater than equal to a plus b plus c by 3. Now again for this, we'll take 3 positive real numbers a, b, c, and again we know m3 abc is greater than equal to m2 abc. So we can write a cube plus b cube plus c cube upon 3 to the power 1 by 3 is greater than equal to a square plus b square plus c square upon 3 to the power 1 by 2. Now if we take square both sides, then we can write a cube plus b cube plus c cube upon 3 to the power 2 by 3 will be greater than equal to a square plus b square plus c square upon 3. So that's our first inequality relationship. Now we also know that m3 is greater than equal to m1. So we can write m3 abc will be greater than equal to m1 abc. So it will be this a cube plus b cube plus c cube upon 3 to the power 1 by 3 and will be greater than equal to a plus b plus c whole divided by 3, and that's our second inequality relationship. Now what we'll do is we'll multiply these two. Now this is a cube plus b cube plus c cube upon 3 to the power 2 by 3 plus 1 by 3. So this part will be 1. So we multiply it, we get a cube plus b cube plus c cube upon 3 and will be greater than equal to a square plus b square plus c square into a plus b plus c whole divided by 9. Now this 3 and 9 will cancel, and if we rearrange, then we can write a cube plus b cube plus c cube upon a square plus b square plus c square will be greater than or equal to a plus b plus c by 3, which is what we need to prove in this question.